will be resistive type sensor. And if the sensor having three pins over there, that can be any different configuration of the sensor, that can be capacitive type or any other kind of configuration over there. Commonly, if you are having only two pins over there in the sensor, those sensor will be resistive type. It's not like that all the sensor will be resistive type, they are having only two pins. Might be that can be capacitive type, but 70 to 80% sensor, those are having two pins, you are going to find those are resistive type sensor over there. So now what we are going to do, we are going to read the sensor value over here. So why we are using this resistance over here? So this one is known as a voltage divider rule concept that is being used in the electronics and electrical. So mean this one is the resistance output we are getting it, and we are using another resistance. When we are going to use two resistance, so the voltage is being divided. Another way we can say over here. So whenever we are changing resistance value over here, so that resistance value is being get converted in the format of voltage deflections. That voltage we can read it over here. I'm just going to show you using multimeter that how it will be get deflected. So now you can see the output, we are going to read it from over here, and this one is the ground you can connect with the ground. So right now we are not reading any sensor value, just we are mounting the sensor, and the output we are going to see it on the multimeter. You can see output, it is showing 5 volt. When we are going to click over there, and when we are going to increase load over there, so what is happening, voltage is reducing over there. So this one is working, the deflection is in the different manner, like when we are increasing the load, so voltage is decreasing over there. So when we want to invert it, so how we can invert it over here? So we can change this ground, we can connect it with the 5 volt, and 5 volt we can connect with the ground. So I'm going to make it red color, and this one is black. So now you will be able to see by default is 0 volt, and whenever we are going to increase the load value or weight, we are going to increase it on the LPG cylinder. Suppose it this one is a LPG cylinder that is mounted on the sensor. You can make a small stand over there, and you can mount this load sensor. Similar kind of another weight sensor also, those are available in the market. Those are also analog type. Working will be the same, code will be the same, only the sensor you have to replace it over there. So now that is working in that way. So whenever we are going to use any kind of resistive sensor, we have to mount this resistance over there. Their value will vary, that depend upon the sensor range of the resistance. Now we are going to read this value, how to write the code. So first of all, by default code is this one, you can delete it. We are going to read the sensor value. First we are going to read the sensor value, then we are going to analyze the value, and we are going to set some threshold value on the sensor range. Then if the sensor is going to cross the threshold range of the weight, we are going to turn on the buzzer, or we can get some different LED indicator also. Like if the LPG cylinder is full, so we are going to get green LED on. If the LPG cylinder is 50% empty, so we are going to make yellow color LED on, and if the LPG cylinder is only 10%, so we are going to make red LED on or something like that. So that indicator also we can make it over here. Right now we are going to mount one buzzer. You can take this buzzer. So you can mount this buzzer. Buzzer we are going to give output. So there is positive. Positive you can connect with any digital pin whichever you want. So I'm going to connect it on the 5 number pin. And this one is the ground that we are going to connect it. Negative one with the ground. You can do color coding also over there. You can make it color black for the ground, and for this one you can make it orange signal color. So now we are going to write code. So we are going to divide this code in a two part. One part is just reading the sensor value, and the second part is based on the sensor value we are going to turn on this buzzer. or we are going to play any sound over there. So go to the code, and you can see over here. So you can write coding in a C++ or Python both. So in which coding you are more comfortable, in a graphical coding or C++ coding? Give your response in the chat box. Which coding format you are more comfortable, in a graphical coding or C++ coding? Okay, embedded
C++,
C,
sir.
graphical. So Yogesh has answered with the embedded C, and Sarita has answered with the embedded C or C++. Okay, so more response is coming over here with the Saurabh has answered with the graphical both. Okay, let me share with you both. So first of all, I'm just going to share with this graphical coding. So go to the input first, and you can see there are different blocks. So we are going to see read digital pin, read analog pin. Second block we have to take it for reading any kind of analog sensor value. You can read it like this, and then now we are not able to read the sensor. What next we have to do over there? We are going to print this value. Whatever value we are reading it in the Arduino, we are going to print it on the serial monitor, so that we can see that value, we can display somewhere. So that is the serial monitor. Over there we can display that value, so that we are going to do it over there. So now how we can print it on the serial monitor? Go to the output, take the block over here, that is, scroll down, print to serial monitor, this one. And simultaneously you can see text coding also, C++ code also. Right now there is no code, empty one over here setup, and there is by default delay, otherwise there is nothing. This one is a minimal code in the Arduino. Minimal means the essential code that is required for compiling the code and uploading the code in the Arduino. Otherwise it will show error over there in the Arduino IDE software. Now you can see this block can be get not fitting over there properly. So drag it and drop it over there in replacement of hello world, like this. Now this one we can fit it over here easily, like this. So again repeating how I have done it. So we have to go to output, take this print to serial monitor, and you can fit it over here. Then go to the input, take second block, that is read analog pin. You can fit it over there, and you can see this one is showing like this. So I'm explaining this one code also, how it will work. So first of all, in the void setup, we have to define the pins, that is input and output, or we have to initialize something that we want to execute in the code. So first of all, the pin mode A0 pin is a input pin that is being defined. A0 pin, we are using it as a input, analog input. And then after that, what is this? This one is a serial begin. Serial begin means print to serial monitor. We want to print the data on this serial monitor. For that, we have to initialize the library in the Arduino coding in the embedded C, that is a serial library. So we are going to initialize that library, and then after that 9600, that is a baud rate, broadcasting rate over there. There are different broadcasting rate in the Arduino that I will share with you later on. So by default is 9600. So that is the data transmission rate, that is bit per second. And without initializing library, we will not able to print it. Then after that, we are going to write the syntax of print serial dot print, and this one is a in, not in, that is known as a ln. So that is known as a new line. And this one is sensor value, we are reading it, syntax of reading sensor value on A0 pin. This one is by default delay. Let me take one more delay block so that we can print the value properly. Yeah, now 1000 mean 1 second. The data over here, that is in a millisecond. The delay in a millisecond, over here we have written 1 second. Okay, so now the code is ready for reading the sensor value, and we are going to check it out how we are going to print the data on the serial monitor. So code is being get simulated, and now you can see the value we are getting it over here. Different values we are getting it. The fluctuating value we are getting it. So let me go to that only the graphical code so that we can see circuit also. Okay. Now you can see when we are starting simulations, value we are getting it fluctuating over there, but the voltage over here is zero. Let me click on the sensor, increase the force value, but still the value we are getting it on the serial monitor, that is fluctuating over there. So why it is so? Reason behind that, we have not connected that signal pin with the analog pin. So this signal pin we are getting it from over here, that we have to connect it with analog pin, A0 pin. This one. This one is the ground. Okay. So this signal we are reading it on the this multimeter also, and as well as Arduino also A0 now. Now you can see how much value we are getting it. Value we are getting it 0 over there now, correctly, whatever we are able to see it over here. Now as we are going to click and we are going to increase, you can see we are increasing the voltage. We are increasing the force, and based on the force, voltage is being get increased over here. So as we have discussed about this resistance earlier, now the voltage we are giving in the Arduino, that is 1.07 volt, but it is showing 219. Why it is so? Reason behind that, there is inbuilt ADC. ADC means there is a magnifier in the Arduino microcontroller. Magnifier means when we are giving voltage over here on the analog pin, that is 0 to 5 volt, it will magnify that voltage in different number. What is that magnification ratio, that we are going to discuss over here? Let me see over here. Wait for a moment. Okay. So now coming back over here in this. So whenever we are going to read it over here, so it will magnify the value. In which ratio it will magnify it over here? So that I'm just going to show you over here, the magnification ratio. So it will magnify in the format of, this will magnify this value whatever we are reading on the A0 pin. So we are going to read the value from the circuit, that is 0 to 5 volt. 0 to 5 volt voltage we can read it over here in the analog pin over here. That is the variable voltage. But it will read in the format of that is in 10 bit. 10 between 2 raised to power 10. So it will read in the format of 10 bit. It will magnify it in this ratio. So when we are going to convert it over here, so it will convert, it will magnify in the range of 0 to 1023. 1023. So that is when we are going to calculate it, that is 1024. So now whenever it going to magnify it over here, so it 0 is also counted over there. So 0 to 5 volt signal we are giving it, it will magnify it in the range of 0 to 1023. When we are giving 5 volt, it will read 1023. So we have to understand that why it is going to show those different values over there. So it will magnify it over there. There is ADC, that is inbuilt. ADC means analog to digital converter, that is inbuilt in this Arduino microcontroller. So no need to get confused about it, why that value it is showing. Now coming back over here. So you can see it will magnify it. When we are going to increase this voltage, you are going to see the number is being increased over here. In the same manner, like 0 to 1023 is maximum and 0 is minimum. So now what we can do, we can set up some threshold limit. Like just suppose this one is the 2.3 Newton. So just suppose 3 Newton, or let me take it only 1 Newton. When the yeah 1 Newton. So when the force is 1 Newton, mean load is 1 Newton over here, that is being taken in a Newton, we can convert it in weight and all that using gravity and all that. So the value is 151 over there. So we can set this value as a threshold. If the force is less than this value, we are going to turn on the buzzer. Otherwise, buzzer will be off. So we can use over here that if and else conditions. So we have to go to the control, and over there we are going to use if then else conditions. Scroll down, and we are going to use if then else condition like this. And now on which value we have to apply the if and else condition? We have to apply this value on the sensor value. We are reading it on A0 pin. So this same block we have to use it. This same block we want to use it over here. So I'm going to copy, duplicate this block, and you can insert it over here. We are not able to insert it over here like this. So one more block we have to add on over there. So for that, we have to go to the math. So this similar kind of hexagon kind of block that we have to take it over here. So for that, go to the math, and second block we have to take it. This one is known as a comparison block. Now this one get fitted. Now you can fit this one. This one block can be get inserted now over here. So if sensor value, we are reading it on E0 pin, is equal or less than, so we have consider over there value is 150. If the value is less than 150, so buzzer should be the on. So we want to give output to the buzzer. If the condition gets satisfied, so go to the control, go to the output, take the block over here for the buzzer. Buzzer block is play speaker. And the pin number of the speaker is for 5 number pin. 5 number pin. So buzzer will be on in else conditions. If the condition not satisfied, again you can take one more block, turn off the speaker. This one. And over there you can see speaker pin is same 5 number pin, and this one will be turned off over there. So buzzer will be on the 5 number pin, and buzzer will be off on the 5 number pin over there if condition not fulfilling the required set condition. So now we can start simulation. Check it out. One buzzer is going to operate. You are going to see those indicators. If you are not able to hear the buzzer, now you can see buzzer is on now. Click over there. If the value is less than 150, you can see buzzer is still on. So this one is the that cylinder weight over there. With the cylinder, so now the value is, you can see more than 155. So you can see buzzer is off. And when the cylinder is going to get empty over there, so buzzer will be on over there. So you can use some LED indication also over there simultaneously this project. I'm going to add on to LED also. So you can go to the output and take again that LED block, second block, LED high, LED low. So one more block, you can take it over here. So you can set up any pin for the LED. So let me take 11 number pin, same 11 number pin over here. So LED will be high, LED will be low. So one LED we have to connect on the 11 number pin for indication. Only one indication, I am doing it right now. So one is cathode, is a ground. So I'm going to connect ground from over here. And this one we have to connect it with 11 number pin. Now after doing the connection over there, so you can do color coding also. This one I'm going to make it green color LED, or you can make color also green or red, whatsoever color is required. Color also you can change in the LED. Now after doing this, you can check it out what is happening. One, you can see LED is on, LED is full, LED is off, and as well as buzzer is also off. Like this. So you can add on two LED also, green and red also. When the cylinder is empty, then red color LED, otherwise green color LED. So for that, what you have to do in the code? So you have to add on one more LED over there. So this one is high, and another LED on the 12 number pin you can make it, or 10 number pin. So same block we have to add on over there also. Pin number is 10. So this one we are going to make it. So over there, this one is 11 number is high, 10 number is low. And over here 11 is low, 10 is high. So alternate we have done it over there. And one more LED we have to connect it over here. So let me connect the LED. So now this LED we are going to connect it, LED negative we are going to connect with the previous LED negative. That connection you can do it neat and clean. And this one we are going to connect it over there on the pin number 10, like this. So this one I'm going to make it red color LED, and this one is green color. So now you can check it out how it is working. So by default, when there is no green LEDs on, you can make it in the code. So you can make it high to low, low to high. Over here also low to high and high to low. Alternate we are going to do it, so that when the cylinder is empty, red color LED should be on over there. So green color LED on and red off. When cylinder is going to get empty, red color LED on and buzzer is on also. So this one is a interesting project that I shared with you. You can use that project in your kitchen also. Right now we have used this one without IoT, and you can add on IoT also over there. So that part also we are going to discuss, that how you can add on IoT over there. So how you can integrate IoT so that you can monitor your LPG cylinder from any remote location. When you are in the office or in your college, you can check it out that how much percentage of LPG cylinder is there in your kitchen, so that whenever booking is required, you can do the new booking when the LPG gas is below the threshold limit. So that also you can do it. So the code when we are going to see it over here, you can see that code in a block plus text. This one is a C++ code. So this one is a pin mode. We are using 3 pins over there for the LED. Those are output pins. We are going to set up conditions if sensor value that we are reading it analog read A0 is less than 150. So this one is a buzzer blow. Buzzer mean this one is a buzzer that is known as a passive buzzer. There is two type of buzzer, active and passive. So active buzzer directly on and off can be managed, but in the passive buzzer you have to set some tone over there. So this one is the tone that we are going to set up it over here, like pin number 5. This one is frequency and this one is the delay. So that is required over there. Frequency you can change it so that you can get different tones over there. So there is one range over there for the frequency. These are different notes you can play it over there. And over there you can see LED low, high, high, low in else conditions. In that way, no tone mean speaker will be off over there. So in that way, you can write a very simple code and you can simulate it and you can check it out over there. And then after that, we are going to move ahead with the cloud part that we are going to discuss. So first of all, I'm going to share with you that how you can make any kind of IoT application without having any kind of experience in the cloud computing, experience in the coding and all that. Without that also, you can start building your IoT applications, IoT projects in a very simple way. You can make customized mobile app also, because otherwise you required Android for building Android app, Android Studio and many more tools is required. But in a very simple way, you can make customized mobile app and you can use that tool. So this one is Tinkercad. Over there you can make your project and you can get schematic view also over there, and that also you can download it as per your requirement, so that you can download it in the PDF format. You can attach it in your file and in your report also, and all the component list also you can see it over here like this. And you can share that project also amongst your colleague and amongst the student. Invite people and you can share the link so that they can edit this one also and they can watch that circuitry also. So that can be done over there. Now I'm going to move to the another tool. With the help of that, you can make customized mobile app. So the customized mobile app, you can make it and you can control the appliance from any remote locations. So for that, we are going to use the tool that is online tool with the name of Remote XY. Remote XY. So how many of participants are familiar about this tool, that Remote XY? Kindly give your response in the chat box. Yes and no, or thumbs up, or that down thumbs up, thumbs down also, and thumbs up also, that you can show it in the chat box. How many of participants are familiar about this tool? Okay, so few participants are familiar about it. That's great. Okay, so Vikas one is familiar, Yogesh not familiar, Ami is not familiar. Okay, let me discuss about it in a detail so that you can get familiar about it and you can start building your own customized mobile app. So in this tool, what you can do, you can make customized mobile app using drag and drop. So you can just drag it and drop it over there like this. Like button you want to control it. This one is another button, on push switch, and this one is on off switch. And this one is slider if you want to increase or decrease light intensity, that you can do it. If you want to control light in your room, different color you want to see it in your light, that also you can do it. Then after that, this one is a joystick if you want to control your remote car, robot or remote car. So that joystick also you can use it. That is also very interesting. So you can use some mobile sensor also over there. Mobile sensor mean you can use your GPS and you can use your gyroscope sensor also over there. So that also can be used over there. So that you can see it over here. And then after that, there is some more tools over there, some sensors, those are embedded in the mobile phone, that also you can use it, like compass, accelerometer, orientations. So some indicators over there that also you can find it, like LED indicator, power indicator, battery status indicator. These are some more linear division levels, instrument, sound. So that also you can add on over there in your customized mobile app based on your application, what kind of application you are going to build in. So now we are going to uh, use it over here, this tool, for simple application right now. We are just going to use a button or switch. Only two buttons we are going to use it over here. One is push button and one is on off switch over here. So you can control your home appliance using this mobile app that we are going to make it like this. Size you can increase, decrease, whatever modification that you want to do it over here. Easily you can do it over there. Now, how you are going to set up it? For that, important point is that for that you require a hardware, and now how we are going to set up over here that simulation part. So that I'm going to discuss over here. So first of all, we have taken two buttons over there. One is, this one is a push button and this one is switch. So how we have to do all the configuration part? First of all, after doing that setup, you can change color also. Whatever modification that is required, that you can do it based on your requirement, so that you can do it over here. Over there also you want to change the color, background color or any other color, so that you can change it. This background color also you can change it. Configurations, view, screen format. You can add over here vertical or horizontal, that also you can do it. Background color, that also you can make it dark or light color, whatsoever color is required, that you can set up it over there. So that color you can set up it based on your color combination, which one is suiting your requirement, that you can select it over there. Then after that we are going to uh, add on over there screen size also you can set up how much size in your mobile phone that is having. Orientation, vertical, square, how you want to make it over there, like in the tablet you want to run it horizontal, vertical, like this. Custom, any customization you want over there or any standard size is required, that also you can select it over. Workspace over there you can increase or decrease, so that you can do it over there. And then after that we are going in the configurations. So in the configurations, before going in the configuration, very important point that we have to select, we have to click over there and we have to select which pin we want to control in the Arduino. We can use Arduino over there, we can use Node MC also over there, so that is up to your requirement. So we are going to use Arduino now, and you can click over there in the button and scroll down over there, slide it downwards, and we have to select pin number, snap to pin. So which pin you want to control in the Arduino, over there in that particular pin you have to connect the relay, so that you will be able to control the real-time AC appliance also at your home using your mobile app. That also you can do it over there. Now what you can do it over here, I'm going to move, going to select the pin, just post 12 number pin for this. Same way, select the pin number over here, scroll down, and the pin number is, let's suppose 30 number pin. And this caption also, like on off, you can change as per your requirement. Light, and you can see light on, off. Over there also you can make it off or on, whatever you want to make it over here, so that you can set up it over here. So I'm going to make it over here off. if you want to change it further any color over there, that also as we have discussed, so that color also you can change it. So that color combination also you can select it. So many customization that you can do it over here. So draw type over there, you can make it rectangular, ellipse type, more attractive, you can make it over here. So the basic part that I have discussed, now I'm going to move ahead that what are the configurations that we have to set up it over there. So that we are going to discuss over here. So for that, go to the app, go to the configurations. So how you can control your appliance via Bluetooth, via Wi-Fi or via internet? There is three more that we can use it. Either using Bluetooth or you can use Wi-Fi also without internet. Wi-Fi means we are going to use mobile hotspot without internet that we want to control the appliance. That also we can do it over here. And the third mode is over here, that is using the internet. So first of all, I'm just going to share with you that using Wi-Fi, how you can control the appliance. And then later on, I'm going to share with you that how you can control appliance with the internet also. What is the advantage and disadvantage when we are going to control the appliance using Bluetooth? There is the range of approximate 10 meter. The Bluetooth range is approximate 10 meter to 20 meters. When we are going to use Wi-Fi, Wi-Fi range is up to 100 meters. 100 meters means your home is being get covered up over there with the Wi-Fi, so that you can control it your appliance from any corner of your home. Whenever we want to control appliance from any remote location, for that you require IoT, Internet of Things, connecting via internet, Wi-Fi connecting via internet. So first of all, we are going to discuss about that Wi-Fi without internet, and then we are going to talk about that IoT part. Because now in these days, sometime if the network is not available, so we can use Wi-Fi, and in many applications, Wi-Fi mesh is being created, and the range is being that enhanced up to 1 kilometer, 2 kilometer also using Wi-Fi meshing. So that is being used in the IoT also in some specific application when we talk about in any forest area and we want to connect different trees and different plants in the agriculture also. So meshing is being created over there, mesh networking. Now we are going to talk about how we can select that Wi-Fi. We have to click on the Bluetooth. We are going to click on Bluetooth. This one is important part. Click over there, and now you will be able to see like this. So we have to scroll it down, and these are the options available over there. So we have to select Wi-Fi access point, and then you can see the module option over there. So click on the module and you are going to find different modules over there. Board is Arduino, we are using it. So this one is a Wi-Fi module that is known as a ESP8266 Wi-Fi module. That you can connect it with the Arduino also, and there is some dedicated Arduino board also over there already. That Wi-Fi module is integrated. That also you can purchase it from the market. So commonly, if you are using Arduino and you are comfortable with the Arduino, and students are also having the Arduino, they have to purchase this one board, that is Wi-Fi board, that is ESP8266. That cost is approximate 170 rupees or 150 rupees. So we can select it, and then after that, all the setup is done over here. We can apply it. Now the configuration is done. Wi-Fi access point, Arduino board, Wi-Fi module. Because Wi-Fi module is required to connect with the Wi-Fi and to create a hotspot. So this module will create a hotspot, and we are going to connect that Wi-Fi with the mobile phone, and we will be able to control the appliance. So after doing this, we have to go to the setting part. That is the second part, setting. The second part is setting. In the setting, we have to select the device name in the app. If you want to give any name, that also you can give it. Any password that you want to provide it, so that for the security concerns, so that any other person cannot control your appliance. So that also you can select it over there. Then the next part is serial interface, that how you are going to connect that Wi-Fi module with your Arduino board. So for that, we are going to select that connection. So we are going to select it hardware serial. There is two mode of connection that we are going to use it, software serial and hardware serial. What is the difference over there? Whenever we are going to connect hardware serial, mean we are going to connect hardware on 0 and 1 number pin in the Arduino. So that is known as a hardware serial connections. When we want to use any other pin in the Arduino, so we can select software and we can change those pins. Any other virtual pins that we can use it for connecting any serial communication device like Wi-Fi, Bluetooth and like that. But we are going to use hardware serial because we are going to connect 0 and 1 number pin for Wi-Fi module. And this one is a broadcasting rate, that how that Wi-Fi module will transfer the data to the Arduino. So over there, what we are going to do, we are going to use baud rate 115200. Why it is so? That is by default baud rate of Wi-Fi module. That is factory by default baud rate that is being set up for that Wi-Fi module. Now this one is SSID, mean this the Wi-Fi module create a hotspot. What should you want to give the name? Any name you can set up it as per your requirement. So let me give it FDP 123, and you want to set up any password also over there. I'm going to make it open, and then after that, that part is okay. Now my setup is done. So what setup I have done? I have done in the configuration Wi-Fi access point, Arduino Uno board, and this one is Wi-Fi module. And then after that, setting we have selected over here, hardware serial, and baud rate is this one, and any name you can give it over there with the SSID. Mean it will the device will create a hotspot, and then after that we can go to get source code. Get source code mean after clicking over there, automatically your C++ code will be generated over there. So this one is your C++ code. You no need to write any single line of code. Just you have to copy this code. So I'm going to copy this code and you have to paste it in the Arduino IDE software. So this one I'm going to copy it and I'm going to paste this code in the Arduino IDE software. This one is Arduino IDE software that I'm going to open it, that you can freely download it from the internet. Like over there you can search Arduino IDE. So that you can download it over here from the internet with the name of Arduino IDE, that you can see it. This one is a web portal, and over there you can find that Arduino board. Not Arduino board, that Arduino software that you can get it over there from internet. So this one is the latest version. So I will recommend you should download any previous version. For that, scroll down, and these are the legacy version. Those are the stable version that you can download it based on your window, that you can select it and you can download it. So the zip file can be suitable for all the windows, so that you can go ahead and you can download over here. Freely you can download it because Arduino IDE is a open source software that you can use it. Now this one is Arduino software that is being get open over there. So over there, how now this one is the minimal code, as I told you earlier. Minimal means void setup and void loop you are required to run this code. So what I'm going to do, I'm going to delete this code, and whatever code I copied it from over there, that I'm going to paste it over here. So I just pasted the code that I have copied it from that website, from the remote XY. So this one is the code that I'm going to copy it and paste it. So after that, we have to follow these 6 steps only. First step is download the source code or copy the source code and paste this code in the Arduino IDE. Then we have to install this remote XY library. How we can do it, that I'm just going to share with you the step. Then third one is compile the source code and upload this code in the Arduino IDE. Fourth one is connect the Wi-Fi module with the Arduino. Then install this mobile app from the Play Store. Remote XY easily available on the Play Store freely, that you can install it. Then after that, connect the board using mobile app. So that I'm just going to share with you. So how to add on the library? Whenever we are making any complex project in the Arduino, we require a library. So we have to go to the sketch in the Arduino, include library, and manage library. In include library, we have to go to the manage library, and over there we have to search the library with the name of remote xy. So we are going to search library over there, that is known as a remote xy library. So it will update it, and after that we will able to see that library over there. So let it get updated. Then we are going to use Wi-Fi over here, Wi-Fi module. So let me share with you the Wi-Fi module that we are going to use it over here. So this one is a Node MCU board, that also you can use it. Over there Wi-Fi is already integrated, and microcontroller is also over there in this board. So this one is very cheaper one, that cost is approximate uh, 200 or 250 rupees. So in that you can get it. We are going to use over here. This one is a sensor shield that we are going to use it over here, because many sensors are already integrated. So over there we are going to use LED to make it on and off. Later on we are going to use other sensor also. So these are the steps that we have to follow whenever we are going to upload the program first time. We have to write code over there. Like we have to follow these steps, download the Arduino, connect the board to the computer, and then after like this USB cable, we have to connect it over here, and we have to connect it with the computer. Code, we have to select the board we have to select Arduino Uno, and the port we have to select whatever port is being displayed over there, and whatever code we are going to run it, we can upload it over there and we can run it. Now over there what we are going to do it, we are going to add on library. So first of all, whenever we have to add on the library, we have to search it over there. So you can search it with the name of remote xy, remote, remote xy. So whenever we are going to search remote xy, so it's saying wait for it, let it get complete. So now it is saying that remote xy library is visible over there. You are going to get some installation option over there. So over there you can see, you can install it. So I have installed the latest version. So after installing, your library part is complete. Just you have to upload this code in the board. So the board that we are going to use it over here, that is Arduino Uno plus Wi-Fi board that we are going to use it. So let me show you that board. Let me open directly. Yes. So this one is Wi-Fi, that is ESP8266, that we can connect it with the Arduino also like this way. So that we can do it separately. We want to connect this Wi-Fi module with the Arduino. So if we are going to connect this Wi-Fi module with the 2-3 pins, so we have to select software serial over there. And if we want to connect this board on 0-1 pin, we are going to select hardware serial that we have discussed earlier. Now another simple solution is, you can use this one board. This one is Arduino Uno as well as Wi-Fi integrated over there. You can use this board as Arduino Uno also, because that same microcontroller is over here. and Wi-Fi chip is also integrated over there. Arduino Uno plus Wi-Fi module. So right now I'm having this module so that I'm going to use it. There is some DIP switch over there. There are different pins. Based on using those pins, you can set up this board. If you want to use this board as a Arduino Uno, you have to on 3 and 4 pin and all other pins should be off. If we want to use this board with Arduino Uno plus Wi-Fi, so you have to use 1 and 2 pin on and all other pin off, like this configuration. So we are going to use only the two function. One is as a Arduino Uno, so 3 and 4 pin will be on. Whenever we have to upload the code, we are going to make it 3 and 4 pin on and all other pin off. After uploading code, we are going to connect the Wi-Fi. For that, 1 and 2 pin on and all other pin off. Only these two configuration we have to use. So after that, that board we are going to use it over here, this black one, and we are going to upload the code. So what I'm going to do, I'm going to connect this my black board over there with the computer. I'm going to check it out in the Arduino. So you can see, close it. My part is done. You can select the tool, and over there board is Arduino Uno. Port is not visible because till now I have not connected my hardware. As I'm going to connect my hardware with the computer, you are going to see the COM port over there. So I connected my hardware via USB to the computer. Now again you can check it out COM port. Now it is showing COM 11. That is my hardware COM port. Sometimes if that is not available, for that we have to update the driver over there. So now we have to select COM port board. So this code we have to upload it on the hardware. First you can verify, and after that we are going to upload it. And then we are going to install the remote XY app over there in the mobile phone. So that step also I'm just trying to share with you in the mobile phone. Okay, so compilation done. You can upload this code using this second button. So the code I'm going to upload it on my hardware. So uploading is done over there, mean my software part is complete. So now after uploading the code, what next we have to do, we want to connect the Wi-Fi. So for that 3 and 4 pin should be off and 1 and 2 pins should be on, in that I told you earlier in the same way. So after that you have to check it out that how many devices is available over there. You can see now it is saying that remote XY123, but we have set up over there that is FDP123. FDP123, that setup we have done in the coding. So it shows that FDP123 hotspot is created now. Now just we have to go to the mobile app and you have to scan. You can see either you can scan directly over there in the mobile app, that QR code, or a few options that you are going to find it over there in the mobile app. So I'm just trying to share my mobile screen over there. Be with me. Wait for a moment. I'm just going to. Sorry. So I'm just going to share with you my mobile screen. Be with me. Okay. So now I'm just going to share with you my mobile screen if that is visible. Let me see. Okay, so mobile screen is visible to all the participants.
Yes, sir. Yes, sir.
Okay, that's great. That's great. Okay, now over there, I'm going to open that app, that is remote XY. So you can open it like this. So I will repeat that functionality also, no need to worry. So now it is showing two devices. So once you are going to do it with your own, you are not going to find any device over there. So first of all, you have to click on the plus button at the right top. Right top, you are going to find that plus button. Click over there, or there is a QR code option also. So using that also, you can scan that QR code as I told you earlier. So now I'm not going to scan it right now. I'm going to click on the plus button, and now it is showing that uh, USB, Bluetooth, and Wi-Fi. So we have to click on the Wi-Fi options over there. And whenever we are going to see it like this, so it is saying that select Wi-Fi point. So you can select Wi-Fi point, and it will show all the available Wi-Fi network. So right now it is not showing my FDP 123. So for that, we have to go to the Wi-Fi setting. See over there all the devices. Refresh it. So that device you have to find it. Then only you will be able to add on over there. It's not showing in my computer. It is showing, but still over there it is not showing Wi-Fi. Okay, let me try to scan that QR code. So that QR code, I'm just going to scan it from my screen. Let me see if it is working. It's trying to connect with the FDP 123. So right now my Wi-Fi is not connected, so it will not get connected over there. So in the same process, we have to follow same as we are going to connect with the this Wi-Fi. Now it is saying that there is error that FTP 123 is not available over here. So let me check it again if that is available. Let me connect and disconnect again. It's not showing over here, but it's showing in the computer screen FDP 123. So what we have to do, we have to select that FDP over here in the Wi-Fi. Over here you are going to find with the name of FDP, that we have to select it, and then you will able to add it. First of all, let me disconnect, might be that is the issue. I'm going to make it on again. Yes, FDP is now visible. Be with me. Let me share that screen again. Yes. Now FDP 123 is connected with my Wi-Fi, and we have to go to that plus button, Wi-Fi access point, select Wi-Fi port. Now you can see FDP 123 is visible. Click over there, and whatever mobile app you have designed, that will be visible like this. And as we are going to click on the buttons over there, and you will able to make on and off your appliance. This one is my mobile screen that is visible to all the participants. So is that visible to everyone, that mobile screen with the buttons? Is that visible to everyone? Yes and no? You can give a response in the chat box. Okay. So now what I'm going to do, I'm going to connect right now LEDs on my hardware. I will show you that hardware also. And I'm going to connect two LEDs on my hardware on pin number that we have selected earlier, that is 12 number and 13 number pin. So let me connect one LED on the 12 number pin and second LED on 13 number pin. Okay, so that I have done it. So now I'm going to check it out, my LED is working or not. Yes, one LED, yes, both are working. So I'm going to turn on the camera, you can see it, that is working. Okay, so now you can see, I'm just going to show you the hardware over here. What I have done all the setup and the mobile screen is also visible, I think. So I'm going to press the button. You can see light is turning on. When releasing the button from mobile app, light is turning on and off like this. And in the same way, I'm going to use the on off switch. You can see light is turning on and off. Switch on and off that we are using it. Off, on. So I'm pressing in my mobile app. I think internet is not connected in my mobile app due to Wi-Fi. So you can see over here in the camera. So I'm going to use this mobile app over here. So I'm going to make it on and I'm going to make it off. From the mobile app, I'm pressing it like this. That is turning on. So this one we are doing it without internet. Only the Wi-Fi we are going to use it over here, and the range of Wi-Fi will be over here. Range of the Wi-Fi will be over here. That will be approximate 100 meters. And now you can see the buttons are we are able to operate it, and that is visible on the screen also, like this, on off on like this. So the speed also very quick and very fast. Now the same setup, this one LED can be replaced with the relay. That connection I will let you know, and then after that you can control same setup using IoT also. That part also I'm just going to share with you. That is very easy. So I'm switching to my computer screen. Okay. So now the setup we have done it earlier over there. I'm just going to share that part, that is IoT. So for that we have to do sign up over there. Then only we will able to do that IoT part, because the cloud we are going to use it over here. We have to go to the editor, and in the editor we are going to find the same app. Just we have to go to the configuration. In the configurations, we have to select over there Wi-Fi, click over there. In replacement of Wi-Fi, we have to select cloud server. In replacement of Wi-Fi, we have to select cloud server, and then we have to apply it. All other part is same. Then we have to go to the setting part, hardware serial same, and this one is Wi-Fi. How it will work? This ESP8266 Wi-Fi module will connect with the internet available network. So that we have to provide it over here. So I'm just going to provide my uh, hotspot my Wi-Fi. That I'm going to update it over here. And the password also I'm going to update it. And this one is the cloud token that we have to select it over there. So the manually we can select that one. So why that is required cloud token that we can separately we can set up it over there. So whenever we are going to connect with the cloud, so that token will be required over there. Like I'm going to select this BB. So this one is the cloud token that we are going to use it over there. You can create a token using this one, my token. Then all other part is same. We have done few setup. Then we have to get the source code. This source code we have to whatever source code we are going to generate it, that we have to copy it. Same step we have to follow it. We are going to copy this code and we are going to upload it. Uh, Delete previous code, paste it over here. Then we have to upload it. So same step, Arduino compo. Whenever we are going to upload the code, we have to turn on, as I told you earlier, 3 and 4 pins should be on. How that will work, I'm just going to share with you PPT. You can see over here, these are DIP switch. So there is 8 pin. So we are going to use 3 and 4 pin for using it as a Arduino. Why I'm just turning it on and off, why that is important? Because whenever we are going to use hardware serial mean that 0 and 1 pin, like those 0 and 1, those are TX and RX pin, those pins are being used for serial communication. When we are uploading code, that uploading via USB using those TX and RX pin. Whenever we are communicating any serial communicating device like Bluetooth, Wi-Fi, that also serially communicating using those same pin number. So if we are not going to make it on and off, so what going to happen? We are not able to upload the code because that Wi-Fi module will be get connected on 0 and 1 pin, and it will be busy with this one. We will not able to upload code from this USB. So for uploading the code, we have to disconnect Wi-Fi and turn only Arduino board. We have to use it using 3 and 4 pin on. That I'm going to do first so that we will able to upload the code 1 and 2 of 3 and 4 on. So after uploading code, we can connect 0 and 1 pin with Wi-Fi using 1 and 2 number pin, nothing else. That is the meaning of those 3 and 4 pin and 1 and 2 pin. Upload the code because now I have just turned on 3 and 4 pin on. Code uploading going on. After uploading code, we have to connect the Wi-Fi. How we can connect Wi-Fi? In this module, 1 and 2 pin we can make it on and all other pins off. Now, how it will work? Now you will be able to see it will not create a hotspot by default, that is previous one hotspot. So it will trying to connect with my available Wi-Fi network. So it is connected or not. How you came to know? You have to go to your token, my token, and you will check out my tokens, and you can check it out that your device is connected or not. Now it is showing that cloud, it is connected with the cloud. Now that is working fine. So what next we have to do? We can go to the mobile app in the same way like earlier we have done. So I'm just going to share with you the mobile screen so that you can see. Wait for a moment. Yes. So I'm just going to share with you my mobile screen. Okay, I think that screen is visible. Yes. So now over there, I'm just going to continue. Wait for a moment. Okay. Okay, now I think that mobile screen is visible to participant. Is it visible to everyone or not? Okay, that's great. So now in the same way like earlier we have opened that mobile app, Remote XY, and we have to click on cloud server now. Now we have to click on cloud server. So let me connect it with the Wi-Fi so that we can get good speed. Okay, now we have to go to the cloud server. And over there we have to use that device token that is being get shared on the my token, and now we have to click on connect part. As we are going to click on the connect part, you will able to see this mobile app. Now how we have connected, my mobile phone is also having internet access, and simultaneously my Arduino is also having that internet access. Now I will able to control the appliance. I'm just going to share with you in the camera so that you can see the hardware. So this one is hardware. Okay, so now, yes, now you can see over here. What I'm going to do it, I'm going to turn on using my mobile app, and light is turning on, and I'm going to turn off previous light. You can make it both light off, turn it on using the switch. This one I'm doing it using cloud, using IoT. Make it off, make it on using that push button, light on. So there is some little bit delay over there, but it is working very smoothly over there, that you can see. Both light you can make it on also like this way. Yes. So that we can do it using that way in a very simple way. Now what I'm going to do it, I'm just going to share with you that how you can connect the relay. So that relay part that I'm just going to share with you. Be with me, I'm just going to share with you screen again. Okay. So now we are going to connect over there relay. So how the relay will work and how we can connect AC appliance over there. So that I'm going to discuss quickly. Moment. So this one is a relay connection that we have to connect with the Arduino for controlling the appliance. Like if you want to control any appliance, so that appliance we can control it using the relay. So you can connect any AC appliance, and like socket we have to cut one wire and we have to connect with the relay. Relay module is available in the market, and using that one what you can do, you can connect the pin number like 12 and 13. We have set up it in the remote XY, and we will able to control the appliance using 12 and 13 number pin. We have connected LED in replacement of LED. We need to connect with the relay wire, relay signal wire, and we will able to control any AC appliance, any heavy load also. Based on that we can select relay also, and we will do it. That is the simplest one IoT application that I shared with you for the beginner. There is some lot of advanced application also. You can make your own customized cloud. You can make your own customized mobile app, and you can do a lot of predictive and maintenance and predictive and alert generation over there on the cloud. But with the limited time, I shared with you the simplest thing that is good for the beginner, and you can move ahead, and you can explore more IoT application in the same way. So now I'm going to sum up this session over here. So, and I'm going to share with you my contact detail also. And we are having a YouTube channel also over there. You can find a lot of more videos related to that one, and advanced IoT applications with the name of Innovate Skill e-learning. You can find with the name of Innovate Skill e-learning on the YouTube. And these are my contact detail. Further also, if you want to know more about IoT or any kind of embedded applications, so you can feel free to contact me. So these are my contact details over here. So now I'm going to take the queries, question and answer over here. If any participant having any kind of doubt, queries, so you can ask over here. So I will be happy to answer your queries. Yes, if any participant having any kind of doubt, queries, you can ask via unmuting your mic if you are able to do it. Otherwise, you can type your queries in the chat box.
Shivani, Shiva Soni and Dr. Jayabu Pathiraja, do you have any question? You have just raised hands.
Hello, sir.
Yes, please.
I am Yogesh Mishra this side. Sir, I have used the relay with the Node MCU.
Okay.
And what problem I was facing that I was unable to control the device on and off. Whereas by using Arduino,
शिवांशी आ जा बाहर मैं लगा देती हूँ
it was working.
Okay. So what happened to your setup that whenever we are going to use Node MCU will operate on 3.3 volt, and relay is required 5 volt minimum. So what you can do, that relay is having three pins. One is VCC, one is ground, and second one is the input. So VCC you have to give 5 volts. Separate power supply you can attach, or separate 5 volt you can give it to that VCC, and then you can give that input signal from the node MCU. Then that will work fine.
Sir, in that case, whether the ground should be connected to the Node MCU?
Ground should be the common in both the supply. Like if you are going to use separate 5 volt supply, so
Yeah.
their ground, node MCU ground should be the common,
Yes.
because otherwise that will not get synchronized.
Yes. Sir, can you just suggest one more pointer? If
Yes,
we are
please.
using Node MCU, then there is only one analog pin. Now, suppose if
Yes.
we are having more sensors which are generating analog signal, then is there any way to use the same Node MCU and utilize
Yes.
more
So for
sensors?
that, whenever we are going to use, whenever we require multiple analog pins, what you can do? So there is ADC IC separately available in the market, analog to digital converter. So that you can connect it, and you can increase number of analog pins over there using that single pin.
Okay, so that IC if we purchase, then with the same Node MCU,
Yes, yes,
we can
multiple
with
analog
digital
sensor
output
you
we
can
can use.
control.
We
Yes,
should use
yes.
digital output. Yes. Okay. What is the IC number of that, sir?
That name I will let you know. You can WhatsApp me. I shared my contact detail. I will share with
Okay.
you detail and that IC number.
Okay, sir. Thank you very much. This is
Dedicated
a huge
module
problem
is
with the Node
available.
MCU,
No need to
actually.
separately attach your IC. So module is available. Just you have to connect VCC, ground, and all pins with the Arduino. So all the connection also I will share with you how we have to do it.
Okay, thank you, sir.
Yeah. So with the help of that, whenever we are going to use Node MCU, so a lot of cost can be saved over there using Node MCU. So there is one drawback in the Node MCU because there is only one analog pin, so you can use separate ADC.
Yeah, actually, when you see students are using Arduino board, then for the Wi-Fi they need use this ESP. It is this another separate IC. That
Yes,
is
yes,
difficult sometimes to configure. Whereas
yes,
no
definitely
is
that
simple one.
happened many times.
Yes, yes, sir.
Okay, so one participant asked over here that one using Tinkercad, the force sensor connected to the analog pin give value ranging from 0 to 1023, that is okay, which matches the 10-bit ADC resolution of the Arduino. How I can connect a potentiometer to the same analog pin? So whenever we are going to connect analog potentiometer, so potentiometer also will give the value that is 0 to 1023. So there is three pin in the potentiometer. One is input, or we can call it, we have to connect with the ground, and the middle pin we have to connect with the A0 pin, and third one pin we have to connect with the 5 volt. So we are going to get only 0 to 1023 value. And the potentiometer also we have to give maximum 5 volt supply, not more than that. Otherwise your Arduino will get damaged. Range value will be the same in the Tinkercad. Let me show you over here because we are having a limited time. Might be all the participants are in the hurry. So quickly, I'm just going to share with you the potentiometer. So you are going to get same range. So let me remove this one, and directly I'm just going to share with you potentiometer. Whenever we are going to connect potentiometer, no need to connect separate resistance because potentiometer uh, is already having that inbuilt resistor, so we can connect with the ground, this one with the 5 volt, and this one is signal wire. Further also, if any participant having any doubt, kindly type in the chat box. I will be happy to answer your queries. Might be sometime you are facing those kind of technical questions while doing any hardware interface. So the code will be same, everything is same. I'm just going to check it out, this code. Only the blocks, serial monitor. So the value you are going to read it over here, that should be in the range of 0 to 1023. That you can see maximum value you are going to get it 1023. Yogesh, hope your query is being get answered.
S- Sir, another one query is there.
Yes, please.
Uh, yes, sir, you have just displayed that. Uh, uh, I think that part, yes, I think you displayed whatever is the uh, analog value that we can send on the cloud. Now,
Yes.
what I want, sir, suppose if the load load on the that sensor, load sensor, if it reaches to particular threshold value,
Right.
right, sir? Then I want to generate some alarm automatically. So whether
Right.
it is possible with this, that I want to know, sir.
Uh, Alarm you want to generate it from the cloud or how?
Sir, see, suppose if the of the cloud we are sending a value when the load of the cylinder is particular level it comes. So it is available on the cloud. We can see that. But what when that value reaches, then automatically one signal should generate from the cloud, and whatever LED or buzzer we have connected to our Arduino, it should turn on. That
Yeah,
operation
that
I need.
also you can do. There are different cloud. You can use it like I'm just sharing with you another cloud that is thing speed. So over there, what you can do, you can generate the trigger also. So trigger mean whenever value is going to cross the threshold limit. So over there, you can generate the trigger also over there in this cloud. So there are different channels you can create it over here, and over there you can set up your trigger also. Like based on any value, you can set up a trigger and alert, and then you will able to send notification in the mobile phone also, and as well as you will able to turn on alarm and buzzer also.
That's a notification generation I have done, sir. By using one app is there, if that then this.
Yes, yes, that
Uh,
also you can do. Like
but the
many.
main thing, I am unable to operate the device, sir. That how I can do that.
So kindly share your project detail with me, and I will try to solve your queries personally, because right now I cannot understand in more detail like what part you are facing difficulty. That I
Okay,
will
sir.
do it.
Okay. Yes, sir. Thank you,
No
sir.
issue. Okay. Further, also, if any participant having any kind of queries, so any simulator that provides the BLDC motor interface with the Arduino. So when we talk about the BLDC motor, so any specific motor you cannot find it over there. But like one more tool over there, few motors, those are stepper motor, you can find it over there. So Walkbee is another simulator. So only basic simulation you can do it over there in the Walkbee. So let me show you some, like over there you can use ESP32, that is similar to Node MCU, and you can send data to the cloud also, virtual data. That also you can simulate it, only the basic part, because this one is not a free software, only limited use. You can use it freely. For Raspberry Pi, there is no any specific simulator. So this one is Raspberry Pi Pico, as I told you earlier. That is a microcontroller recently launched by Raspberry Pi. That is also very cheaper, and over there you can do programming using Python also. So there are some projects also; those are available in this Walkbee. So over there, whenever we are going to use this Walkbee simulator, you can find many sensors over there. Like I'm just going to open it, and you can find some motors, a stepper motor, you can find it over there. This one is the analog multiplexer over there that you can see when I see. So some stepper driver you can find it over there, like stepper motor driver over here, that you can use it. And when we talk about BLDC, any specific BLDC driver you cannot find it over there in any specific software also, that is not available. So hope you enjoyed it. If you enjoyed this session, kindly give a thumbs up over here. And further also, if you're having any doubts, so you can
Sir,
ask
it
questions.
was a very well presented session.
Thank you, madam. Thank you so much.
Going by the thumbs up signs and the comments in the chat box, I think the participants enjoyed more than and learned the various aspects of IoT and how to construct Arduino, work with the Raspberry Pi and all that. So thank you so much, sir, for this hands-on session as well as the other session one, for being there in this faculty development program and providing such engaging session with the participants. So thank you, sir, once again. And we will meet tomorrow on day 5 of the faculty development program.